Hi, I'm Linzy Lemming, a senior in animal science at Iowa State University. I am presenting on a topic that may be touchy for some horse owners. This presentation is meant to inform horse owners what the proper rider-to-horse weight ratio is. People have been using horses for hundreds of years for a multitude of tasks ranging from ranch work to transportation to pleasure. But through technological advancement in agriculture and everyday life, the horse has become more of a companion animal than a working animal. Along with these advancements have come increased height and weight of people, while horses have stayed the same size. 100 years ago, women were less than 5 feet tall, and men were 5 to 5.5 feet tall, with no extra fat. However, today women average 5 feet 7 inches and weigh 145 to 185 pounds. The men of our generation are well over 6 feet tall and average 175 to 225 pounds. With the transition of how horses have traditionally been used to how they are currently used comes a change in how they are treated. The horses of the past were typically treated like other livestock animals, but today are treated with more luxury. Horse owners go to great lengths to care for their horses, especially the horse's back. There are chiropractors, massage therapists, and acupuncturists to aid in the comfort and care of the horse. But one thing most horse owners do not think about are the effects of their own weight on the horse's back and performance. Added weight on the horse can lead to poor performance, back pain, and even health concerns of the animal. So what is the proper weight that a horse can carry? This question is hard to answer and has caused some controversy and uproar amongst some horse owners. A British horse practitioner, as reported by Neil Clarkson, has suggested 3 weight categories. The weight ratio is considered optimal if the rider weighs less than 10% of the horse's weight. Satisfactory is 10 to 15% of the horse's weight, and if the rider weighs over 20% of the horse's weight, it is considered a potential welfare issue. These categories are just suggestions, but there may be some truth behind these ratios. Dr. Hayley Randall, an equitation scientist in Britain, conducted a survey on rider-to-horse weight ratios and found only 5% of riders involved in the study met the ratio for optimum threshold. 32% of riders weigh more than 15% of their horse's weight, and the remaining 63% were 10 to 15% of their horse's weight. This suggests only 1 in 20 riders meet the optimum weight range for their horse. A third of recreational riders are too big for their horses, and 2/3 of riders fall within the satisfactory range. This table shows some examples of what the carrying capacity would be for horses at different weights. For example, a horse that weighs 1,000 pounds can carry 20% of its body weight, can potentially carry 200 pounds. A study was conducted by Powell and others to determine how much weight a horse can carry with minimal stress. Horses in the study were measured for weight, height, cannon bone circumference, and loin width. The horses used were kept at a constant weight, and any horse with signs of lameness was removed from the study to minimize potential variables. Heart rate, respiration rate, rectal temperatures, plasma lactate levels, and serum creatine kinase levels were measured directly before and after exercise, and then again a few hours after exercise. Muscle soreness scores were also scored 24 hours before exercise, and then again 24 hours following exercise by the same massage therapist. The results of the study concluded that a horse that carried 25% or more of its body weight showed increased respiration rate, heart rate, and increased lactic acid concentrations. Horses that carried 25% of their body weight also had increased muscle soreness. These results show that carrying these heavy amounts put added stress on the horse, which may result in unwanted injuries. Powell and others also recognized a potential for cannon bone circumference and loin width on the changes in muscle soreness, meaning the bigger the cannon bone and the wider the loin, the more weight a horse can potentially carry. A key thing to remember is that these percentages include the total amount of weight the horse is carrying. Horse owners and riders often overlook the weight of their tack, including the saddle, bridle, saddlebags, and other gear that the horse is carrying. These weights should be included when deciding if a horse can carry a certain person comfortably. Another overlooked detail is mounting the horse. Clayton found that extra force and pressure is being exerted on a horse's back if mounting is accomplished from the ground, using just a stirrup. It is suggested that a mounting block is used to reduce this initial force and pressure on the horse. It is also important to use a well-fitting saddle on a horse. Clayton and others observed the pressure exerted on a horse ridden bareback and with a saddle. This study used 7 Arabian or Arabian cross horses and 1 experienced rider. Only 1 rider was used to minimize the variabilities. The study showed that riding bareback reduces the surface area and concentrates the weight of the rider, which results in pressure points. As seen in the graph, the pressure of the saddle can be seen on the left and the bareback on the right. As you can see, there is more weight distribution, with the saddle causing less pressure to be exerted in concentrated areas. The graph for riding bareback shows less surface area and higher pressure being exerted. In conclusion, the horse and rider weight ratio is crucial for the performance and well-being of the horse. More research is needed on how the cannon bone circumference, loin width, and horse condition affects the amount of weight that a horse can carry. And finally, saddle fit and mounting, while often overlooked, is critical in reducing pressure on the horse's back. Thank you for listening, and I hope you have learned what size horse would be right for you.